Okay, today we'll be talking about field axioms. Now to start with, let's just talk about what a field is and what an axiom is. A field, for the intents and purposes of mathematics, which is what this is going to be about, is anything that you've probably worked with before this point, before being introduced to the term field axiom. The real numbers, so 1, 2, 3, 4, and basically how algebra works within them is what a field axiom is, the rules that govern this whole system that we've set up. And anything that does not follow by these rules is not a field. So you can categorize things between field and not field. And that can be kind of important. So let's just get into what each of the field axiom is. Alright. Let's just divide them into two categories so that we can sort of see that there's sort of two groups of field axioms. Addition and multiplication. Alright. There are 9 field axioms. One of them is common to both multiplication and addition, but there are 4 that are unique to addition, 4 that are unique to multiplication. Okay. Let's start with associativity of addition. A plus B plus C equals A plus B plus C. Alright, so this just means if you add A and B together, then you add C to that, that will equal adding B and C together, and then adding A. Alright. That hopefully makes a little bit of sense. And let's go on to B plus A equals A plus B. Again, not exactly groundbreaking, but fairly fundamental. You take B, then you add A to it, and that's the same thing as taking A and then adding B to it. Fair enough. Now this one is the one that's common to both, so we're going to take A multiplied by B plus C, and that's going to equal A times B plus A times C. Okay. Alright. Now, the identity for addition is 0. That just means if you take A plus 0, that will equal A. If you take any number plus the identity for that field, that is always going to give you the number back. Alright, now we're going to go for inverse. The inverse for addition is written as negative A. And this means that you just take A plus its negative equals 0. Alright. This isn't always going to be 0, and this isn't always going to be negative A, but you sort of get a picture of what they're useful for, and you relate back to what you've seen them in before. We'll get back to when negative a isn't negative a later, when we look at fields that aren't exactly in our common definition of a field. Alright, so now multiplication. We're going to go a, b times c equals a, b times c. And this is the associativity of multiplication. A times b times c is the same thing as multiplying b times c times a. Okay? That doesn't seem too bad, does it? Alright. A, b equals b, a. Alright, so it's just a times b equals b times a. Enough said. Alright. A times 1 equals a. This is the identity for multiplication. And right over here we have a plus, I'm thinking about inverse for addition. Shouldn't be doing that. One. So this is just a number times this number will give you the identity. That is what the inverse is. You've heard that it's maybe 1 over that number, and for most fields that's true. And in some things that aren't even fields, we use the term identity to work with that anyways. Alright, this is all. Maybe next time we'll do an example, and then hell, we can be happy and know how to work with fields.